الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmina.
Hi, good evening. Good evening, everyone. My name is Samia Ashraf. I am a Flutter developer working at an IT startup here in Dubai. So I've been working with Flutter for past 2 years now, and I love learning about new concepts in Flutter and also talking about them. So my topic for today is enhancing Flutter apps with animations. So let us look at our agenda for today. So we'll start by talking about what are animations and what are the different types of animations in Flutter. And then we will look at the first type of animation, which is code based animation, and the different types of code based animations. The second type of animation, which is the drawing based animations. And finally, we will look at what are the things that we learned from the session. So, what are animations and why do we need animations? And how is an app with animations different from an app without the animations? So, animations in simple words are visual elements that will add up to enhance a user's experience in using the app. So, using animations, you can transform a very simple app into a very engaging application. And if you see here on the slide, at the top right, I have two mobile screens that show without animation and with animation. So, sorry. So the one without animation looks less engaging. It's just a circular progress indicator that does not have animation, and the one on the right side is with the animation. So the animation has been added there, and you will notice that it looks a little more engaging and more appealing. And at the bottom left, I have two screens without animation and with animation. So just a second. Okay, okay. Um, all right. So yeah, so at the bottom left we have two screens without animation and with animation. So the one without animation is just a simple inkwell widget, and the one at the right is actually it has bounce effect whenever the container is clicked, and that has been achieved using the animations. So let us uh, let us look at why we should have animations in the application. So the reason why we can have animations is to make the UI look more appealing, and it will also provide a better user experience in an application. So here I have a screen. Um, So yeah, all of the components there, they have animation. So having a dynamic, like animated screen is way better than having a static screen. So, and also almost every app nowadays they use animation. The animation does not have to be very complex one. It can be the simplest kind of animation also. So the different types of animations are code based and drawing based. And as the name suggests, code based animation is where you use a very simple Flutter widget and you write code on top of it to make it animate. So that becomes an animated widget. And drawing based is a completely different type. You use an animation that exists somewhere on the internet using the third party packages, and then you import it in your application. Like we have the Lottie files and also the Rive files. And code paste can in turn be divided into implicit animations and explicit type of animation. Implicit animation is when you want to have the simplest form of animations in your application, and they are also of two types called built-in and custom, which we will explore later. So just note that implicit animation is when you want to have simplest kind of animation, and explicit is when it's for a little high level animations, when you want the user to have control over animation. So let us look at them in more detail. So the left side here is a code based animation, and here there are a total of 9 containers, and every time you click on a container there is a certain animation that appears. Whereas the second type is drawing based. So like I said, this kind of animation, the drawing based animations, the animation file appears somewhere on the internet and then we import it into our application, and that's how you use drawing based animations. So here it has been drawn by somebody and it has been also animated, so the complete file is what we will be using. So in that case you don't have to write any kind of code, you just have to simply import it into the application. But for code based, it is heavily dependent on code. You can code the existing Flutter widgets to create code based animations. And in the code based animations, like I said, the existing Flutter widgets are coded to perform the animation. Like, for example, the two screens I have a container on the first screen there, and that is implicit animation. So every time I click on the star button, the container will change its size. So this kind of animation is called as implicit animations. It's for the most simplest form of animations. And one thing about implicit animation is that once you perform the implicit animation, you cannot come back to the original state. Like, for example, I have a starting value for a container and I want to change the size of the container. So I make it animate. And once I perform this animation, I can no longer go back to the original size of the container. So that is one thing about implicit animation. It only is a one way animation. You cannot go back. But explicit animation, like I said, you give control to the user to control the animation. So let us look at that in more detail. Implicit animation here, they are often called as animated foo widgets, where foo is nothing but the Flutter widget. And you animate the Flutter widgets to make it to achieve the animation. So some of the animated foo widgets are animated container, animated align, and there are many more. So yeah, so here when I click on the star button, the size of the container changes. And the way we can achieve it is whenever the elevated button is clicked, There is a random number that will be generated and assigned to the width, and a random color will be generated. And all of these variables are enclosed within set state, so that every time the button is clicked, the animation appears and the container will change the size. And this is the code for the animated container. And you will notice that this is different from the regular container because there is an extra parameter called as duration. So that this duration is which is during which the animation will appear. And also notice that color, width, and height are the variables that have been assigned using the random numbers whenever the elevated button is clicked. So, okay. So implicit animation is where, like I said, you will start from a starting state and you will have a target value. From the starting state to the target value, the animation will appear in a certain duration. And this type of animation is comparatively easier because you only have to tell what is the target value. You don't have to tell how the animation needs to be performed. So you just give a target value and the animation will appear on its own. And this type of animation only supports one way. So you can only go from starting point to the target value, but you cannot come back to the starting point. If you want to come back to the starting point, that is, repeat the animation or reverse the animation, then that becomes the explicit type of animation, which we will explore later. So, yeah, I have two screens. One is without the animation and one is with the animation. The one without animation is designed using Inkwell widget, and the one with the animation is using an animated container. So the second type of implicit animation is the custom implicit animation using tweens and tween animation builder. So what is tween? So let's say I have something like a slider, and whenever you change the value in a slider, let's say from point 1 to point 5, there are a lot of values that changes, and for every value that is changed, the slider will update itself. So if you want to add animation in such kind of widgets, then we will use something called as tweens. So tween is nothing but in between. So tween will accept a starting value and an ending value, that is the range. And during this range, every time the slider changes, the slider will update itself. So, so this is the code for that. The tween animation builder will accept a duration, the duration during which the animation will be performed, and also a tween object. So tween object will accept the starting value of the slider and the ending value of the slider. And every time the slider changes, the tween animation builder will rebuild the slider, and it will also, the builder here will accept a context, build context, a double value, that is the value that was changed from the during the sliding, and also a child widget, which is the slider. So every time the value is changed, the slider will rebuild itself. The next type of animation is called as explicit code based animation. So we saw that implicit is the most basic form of animation. You just have a container and you try to change the size of the container. Once the size of the container is changed, that's it. You cannot go back to the original size. So if you want to go back to the original size, then we will use something called as the explicit animation. So, in explicit animation, the user is having more control over the animation. They can control how to animate the object. In this case, let's consider the example of a container. They can either stop a container, pause, reset, or even um, start the container. So, how does the user control the animation? The user controls the animation using the animation controller class. So, whenever we in a stateful widget, if you want to add animation, you will have to use something called as animation controller, which will in turn use single ticker provider and also vsync. So single ticker provider and vsync tell the Flutter that the widget is using some kind of animation and that the widget needs to be notified about the animation. And it will also, it's always a best practice to dispose the controller in the stateful widget in order to avoid the memory leaks. So animation controller has several methods. So like I said, a user can control the animation using these five functions. So we have a repeat function. So repeat is when if the user clicks on the repeat button, once the animation starts, it waits till it finishes the animation and then it restarts itself. So it keeps on repeating. So if you want the animation to keep on repeating, then you have to use the repeat function. And forward is when you start with the animation and then you wait till the animation finishes and that's it. It does not repeat itself. So it's more like a start and then stop once you finish. And reverse is when, let's say, you've started the animation, and if the user clicks on the reverse button, it stops at the current state and then it starts reversing the animation. So stop is when you start the animation and then you stop at the current state. If the user clicks on the stop button, it stops at the current state. And reset is when you stop the animation but then it resets itself to start. So it's more like repeat, but then you stop and then you repeat from the beginning. So they are an extension of the animated widget. So here I have the repeat, and the way how we use the animation controller is there is an animation controller widget that accepts duration. This is the same duration for the animation animating the widget and the vsync. And you will also say if it is repeat or forward reset or that we will be mentioning it here. So the explicit code based animation, they are also called as foo transition widgets, where foo is again the Flutter widgets that will be animated. In implicit animation, we saw animated foo widgets, and in explicit, it will be called as they are called as foo transition widgets. And some common foo transition widgets are fade transition, rotation transition, and there are many more. So yeah, so here so let us look at the example of a rotation transition widget. To rotate, so here I've used a container and the container will rotate. So you have to include the animation controller, and here it will specify the duration and it will also use the vsync. Along with that, I have said that the type of function that it will be using is the repeat function. And let's look at the rotation transition. So you will notice here that I've used a container widget that is wrapped with the foo transition widget, which in this case is a rotation transition. So what this will do is this will rotate the container and it will keep on rotating. It will repeat itself because here I have told that the controller should be repeating itself. So the yeah, so it will keep on rotating. until the user manually stops them. So, and in the same way, you can have fade transition widget. So, fade transition is where the container will fade itself, and then if you put the repeat function, it will fade completely, and then the entire container can be viewed again. The next type is using the animated builder. So let's say I want to rotate a container but at a given angle. Now this cannot be achieved using the normal container. So what I will do is I will wrap the container with the animated builder, and I will tell that it should be rotating at a certain angle. So this angle, we can explicitly set the angle, and it will, the builder here will take the child, which is the container that we have used earlier. So the second type of animation in Flutter is called as drawing based animations. So we have two packages here. So these are third party packages. And like I said, these are drawn by a third party and it has also been animated by them. So these files exist on the internet and we just import it into our application. So the two common ones are Lottie files and Arrive files. And this kind of animation can be used to perform high level animations. So the Rive animation, we can explore. There is a library of animations in their website, and you can either download the animation file, store it in the assets folder, and then declare the assets folder in the pubspec.yaml, and you will be using the Rive animation dot asset widget, and the string will be the path to the animation file. That's all you have to do. With just minimal coding, we can perform the animation. And you will also notice that the only code here is to import the animation from the assets folder. We don't have to draw it, or we don't even have to do the animation part. And if you want to use the URL of the animation file, then just copy the URL, and we'll be using the lottie.network application widget. And the string here is the path to the URL to the animation file. And also here, with just minimal coding, we can perform the animation. So, drawing based animations are comparatively easier because you don't have to code anything. You're just importing the existing animation files. But if you want to have more control over the animations, then it is better to use code based animations because you can code it according to your requirement. So some of the points that we covered are the two types of animations, that is code-based animations and drawing-based animations. And I hope you can now take a decision as to what kind of animation you would want to use in your next project. So the key points to remember is that implicit animations are for the most simplest form of animations, and the key point about implicit animations is that there is only one way of animation. You can only go from start to finish, but you cannot repeat the animation. So, for example, if you're trying to fade a container, you can go from a completely opaque to a complete container, but you cannot come back to the opaque state. And the second type of code based animation is explicit animation. So this is where you can experiment with the Flutter widgets and you can come up with your own kind of animation. And also, the user will have complete control over the animation. They can either repeat the animation or reverse the animation, and even stop the animation. The second type of animation was the drawing based animations, which is using third party packages like Rive and Lottie. And yeah, this one is with the minimal code. With minimal code, you can add high level animations to your applications. And yeah, thank you. If anybody has any questions regarding the animations, you can post them in the comments and I will try to answer them. So there is a question by Miss Hajar asking, can we apply an example by coding? So yeah, like you can, for the simplest kind of example could be a container with height and width, and you can also, if you want, you can also add color to it, and you can have a button that such that once the button is clicked, the container will change the size. So that can be achieved using the animated container example. So the animated container widget is how you can apply the simplest form of animation. I hope that answered the question. Okay, that's great. All right then. So there's one question. What is the animation extension that can be deployed in the Flutter project app? Animation extension? I did not get the question. So, So the anime, there is no really, not really any extension, but if you want to use the animation controller, then there is an extension called as single ticker provider mixin that will be used along with the vsync. So that is one extension that you can apply whenever you're using the explicit uh, explicit animation with the animation controller. And there's one question from Mr. Talal asking, can we add any type of animations? Yes, so based on the requirement, you can either select the code based animations or the drawing based animations. And drawing based animations, I would say, are the most simplest kind of animations because you're not really writing any code for it. You're just picking a file from a third party library and importing it into your application. And uh, yeah, and if you still want to code any of the widgets, then you can use the implicit animations, which is the simplest forms of code based animations. I hope that answered the question. So there's one question from Mr. Atif asking, does animation make the app slow? Animation does not really add to that because yeah, it does not really slow the application, but yeah, I don't think I have ever faced that issue. So yeah, it does not contribute to that. And Mr. Muhammad asks, can we optimize the animation graphic deployed in the Flutter project app? So format. Okay, so the animation extension format. So if you're using a third party package, like for the Lottie files or the Rive files, they have the Lottie especially has multiple types. So you can use something called as the JSON extension. So yeah, JSON, you can use the JSON extension or you can even use the GIF extension. They both work fine. So yeah. Okay, so that was all for this session. I hope you learned at least something about animations. You can always explore more, and Flutter has excellent resources to help you get started. And yeah, you can. They have excellent resources, so please do refer. And yeah, thank you, everyone.